we usually stop recording at the Q&A session?
Yes, so we'll record the presentation and then we'll stop before final Q&A. So if you would like to ask anything that you don't want recorded, you can do that as well.
Okay, great. All right. So as I mentioned, we're gonna, we thought a good way to approach how to develop and use DEI baseline data is with two concrete examples. So we're gonna give you an example from Maryland and also from South Kansas today. Next slide, please. And before we start, I just want to do a quick poll. Can you, let's see, Pearl will launch the poll in a second and just indicate, what data sources do you use to measure DEI baseline data currently or in the past? What methods do you use to track progress on goals, and what are the greatest challenges you've encountered in trying to measure? Okay, let me see the poll. Pearl, should we be able to see responses in real time?
So Alison and I can as co-hosts, and then I can share the responses once we close the poll. Yeah.
Okay.
So whenever you're ready to close the poll, let me know.
Okay. Can you, whenever we get to, I think a little over 50%, that's fine.
Okay. Sounds good. We're at about 25%. So if a few more people want to just quickly put their answers in, that would be great.
Okay. Okay, it's probably fine.
I'm sharing the results. You should be able to see the open responses you won't be able to see, but just to get an idea of what data sources people use.
Okay, so great. So it looks like, oh, it disappeared. Thanks. It looks like most people who responded, 75%, are familiar with the American Community Survey, where you can look at employment by race, ethnicity, and gender. It looks like people are also very familiar with Quick Facts, where you can look at population data for state, counties, localities, also by race, ethnicity, and gender. National Center for Education Statistics, the IPEDS data is degree data by field of study, and again by race, ethnicity, and gender. And then the Argonne National Lab created, I like that acronym nerd, a platform to pull in other data sets that economic development representatives often use to analyze data, economic development researchers use to analyze data, and that was one of the ones that was least represented. I don't know if people that selected other, I don't know if people want to shout out examples of other data sets, but I think everyone would be interested to hear. Or you can put it in the chat also. Okay. And then Pearl, what did people say for methods used to track progress on goals?
Me one second to pull those up, and I won't be able to share what
That's
share
fine. You could just read them.
Yeah, I can just give it a highlight. So for methods to track projects, sorry, my Zoom wants me to log in again. We had about half the people filled out sorry, my computer has frozen. Can I come back with the?
Yeah.
Thank you. Sorry about that.
That's okay. Okay, we'll return to the poll answers later. Okay, Alison, you can go to the next slide. Okay, so Alison and I, and Pearl also, recently completed a study for the state of Maryland. And this was the innovation competitiveness study. And the two questions that the legislature wanted answers to was, how can Maryland generate more high-tech industry growth because GDP growth has been lagging? And then how can Maryland increase participation in the high-tech jobs or advanced manufacturing jobs that are created? How can all Marylanders access those higher wage jobs? Next slide, please. So one of the things we did first was to measure the size of current STEM employment by race, ethnicity, and gender. And so we just have two examples of ethnicity and race here. So you can see that Hispanic Marylanders at the top account for 11% of the employed workforce in Maryland. Black Marylanders account for 29% of the employed workforce in Maryland. Women of any race or ethnicity account for close to 50% of the employed workforce in any jobs. But we were interested in looking at STEM occupations, so we analyzed the data, the American Community Survey data, for computer and math employment, life, physical, and social sciences employment, and architecture and engineering employment. And we looked at the past 10 years growth rates in employment by race, ethnicity, and gender in these three different science, technology, engineering, mathematics occupations. And we found some really positive things, and we found some negative things. So for example, Black Marylanders are very close to parity in computer and math occupations. So when asked the question, what occupation are you employed in? 27% of Black Marylanders identified that they were employed in a computer and math occupation, compared to 29%. There were 29% representation of the entire workforce. But conversely, if you look at architecture and engineering, they only account for 14% of architects and engineers working in Maryland. And so when we calculated the employment growth rates in these different occupations, we found that while all else being equal, while Black Marylanders should close the parity gap in 6 years in tech occupations, it would take 367 years to close the gap in engineering. Next slide, please. And so then, the obvious question is, well, what's driving that? And, why is the gap so big? So one thing to keep in mind is it's very important how many jobs are even available, right, to people. And so when we looked at the different NAICS codes, and this is just one example, but when we look at computer systems design, which was one of the largest industries in the IT area, there's also software and information and data processing and other NAICS codes. But when we looked at computer systems design, approximately 81,000 jobs, and the employment concentration is 2, but it's growing. Even though it's big, it's still growing at a pretty rapid rate, 2.3% a year for the past 10 years. On the other hand, if you look at Maryland's manufacturing sector, the industry is really lagging. So a lot of jobs, but for the size of Maryland's economy and for the number of jobs in the economy as a whole, the location quotient is just 0.5, and employment growth has been negative over the past 10 years, declining by 0.2% a year. So of course, as you're thinking about the educational pipeline and how diverse the pipeline is becoming, when those students of color graduate, right, what jobs are available? And so in Maryland, the manufacturing jobs for engineers are going to be fewer, but the IT sector is providing a lot of room for growth. And then also, a second consideration is just the barrier to job entry. So of course, it depends what type of IT occupation you're trying to enter, but for many jobs, you can be self-taught, you can get industry certifications, you can attend software boot camps or other boot camps, you can get associate's degree, bachelor's degree. And so the barrier to job entry into the industry is low. And for engineering, it's much harder, right? You typically have to be an engineer, you have to usually have a 4-year engineering degree. To even get into an engineering program, you have to take in calculus and physics in high school, you have to have taken algebra in 8th grade. So it's just the barriers are more, there are more barriers to entry. Next slide, please. So in our recommendations to Maryland, based on this analysis, the clear thing is that Maryland needs more manufacturing companies and much faster job growth to generate the kind of demand needed to expand the number of engineers who are hired. And then hopefully you would see, right, people of color also represented in those engineering jobs. And then on the other side of the coin, students of color and first-generation college students, there needs to be, of course, a continued exposure to higher level math and science classes, experiential learning, and then when they're in degree programs, more co-ops and internships to be competitive for jobs when they come out. Next slide, please. Okay, now I'm going to hand it over to Dana Shire for the South Kansas Coalition example.
Hello. So here in the South Kansas Coalition, we're centered at Wichita State University, Wichita, which is also known as the air capital of the world. You can see by our location quotient, we have a pretty high concentration in manufacturing, but we're especially specialized in aerospace products and parts manufacturing. Some of the impacts that we've had since COVID are obviously just the COVID shutdowns. And just prior to that happening, we were adversely impacted by the 737 MAX grounding. One of our largest employers, Spirit AeroSystems, is a large provider to Boeing in building that aircraft. So when that happened, when March 2020 happened, we kind of had that dual impact of a massive workforce shortage in that area. So we wanted to focus on increasing the manufacturing productivity through both technology development and adoption. And that would be more on focusing the manufacturing industry to move into the industry 4.0 and more automated types of jobs and production capabilities. And we would do this with our supply chain as well, since there's a lot of tier 1 and tier 2 suppliers in the area. And so some of our workforce components that we've are focusing on, of course, is to diversify our talent pipeline, and then also to look at what are our current demographics in the area. So some of the things that the university have been doing is we have been identified as an emerging Hispanic serving institute. So we have nearly between 20 and 25% of our population are Hispanics. We also are mindful that we have a huge out-migration problem in the area. So many students and just the population in general is leaving the city. So we've focused on the I-35 corridor, which would come from Texas on up to Nebraska and Iowa. And so what the university has done is to provide in-state tuition for residents in those states to draw more students coming in. And that has actually had a really positive impact on our enrollment numbers. A big focus as well is on those applied learning opportunities. So ensuring that there are opportunities within the programs, especially on your STEM related programs, so that the students get those job opportunities while they're still in classes. And then another focus is on our first generation college students. So while Wichita is the largest metropolitan area in the state, outside of Kansas, Missouri, which does focus on Kansas and Missouri. So in the state of Kansas, Wichita MSA is the largest. But we have about 50% of our undergraduate students are first generation college students. So being mindful of those barriers that students come in with who do not have any experience with the college system. And then one of our partners in this grant is WSU Tech, which is the largest 2-year technical college in the state, and they have also a high percentage of first generation and Hispanic students as well. So if you want to go to the next slide, I'll kind of talk about the demographics of our state and our region. So statewide, we're largely white and non-Hispanic. Moving into the South Central Kansas Economic Development District, it looks pretty similar, but then when you move into Sedgwick County, which is the county in which Wichita resides, we are getting more diverse. And so we've seen over the past few years, decades, I should say, that the Hispanic population has definitely increased. And so being mindful of, where that population is, and are we as educational institutions trying to serve them as best as possible. Whereas on the flip side, you can see Rice County on the right side is a rural area, which is largely the South Coalition as far as number of counties, which there's 27 counties in the South Kansas Coalition region. A large portion of those are rural areas. So you still have that demographics of mostly white first generation college students that are going to be serving that area. So there's a little bit of background on what our region looks like.
Thank you, Dana. All right, we'll turn it over to Alison, who's going to just talk about how she compiles data for the analysis.
Hi, everyone. I'm going to be walking you through some of the data that we've looked at and how we can compile it for the analysis that we've done and how you can do a similar analysis. So the first thing we're going to look at is the table from the previous slide on how we got this demographic data. So we're going to see how can we collect this ourselves, and we're going to use the South Kansas as an example. So the first thing is all of that data comes from the census, but there's different platforms that you can use to access the data. So the first platform we're going to look at is hosted by the Census Bureau, and it's called QuickFacts. It's a handy tool that you can use, and what you'll see, do you still see my screen? Okay, great. So what we'll do is you can Google what you're interested in. So we'll look at Kansas, and we'll Google Kansas QuickFacts. And what comes up will be this table here, where it'll have these quick summary stats from the census. It has a lot of different statistics that we can look at, but the things we're focused on for this analysis are race and gender, but we can find a lot of other interesting information from this table. So this is a good tool to use. So let's say once we get the table set up, we want to look at something in addition to Kansas, we want to look at Sedgwick County. We can come up to this search bar over here, and then we can look up more data related to the counties we want to add. And so then once you select your geography, it'll add a new column to the table where we can get the data related to that, and we can compare them side by side. So this is a really great tool for getting state level and county level data. And so we recommend this being the first place you look to pull data for the demographic statistics. The second place that we can get data from is from the Argonne National Lab. They've created a dashboard that's called the NERD dashboard, where they've aggregated the different economic development districts. And so if you and your coalition has an economic development district, this can be a really useful tool for you to use because you can pull data specifically related to the aggregated district that you're in. So what you need to do is come to the dashboard, and you'll need to select demographics, which I'll go back and show that one more time. So you'll select your demographics tab, and that'll open this dashboard here where you'll have lots of summary statistics. So then you'll select the geography you're interested in. So today we're looking at Kansas. And then we're looking at the South Central District. And then you'll see how that populates the dashboard down below. We recommend sticking with just using the table for pulling data because there's some issues with the map, but generally the table has the good data that you can use. And the other thing to note when you're selecting your geographies is if you do want the full district, make sure that this is selected as all, because that'll sum up all the sub-counties that you're interested in order to get the full district's data. And then you can see here, this has a similar setup to the QuickFacts table where it has our demographic percent of total and then our gender percent of total as well. So that's something to keep in mind. So those are two tools that can be helpful for you when you're collecting data on demographics. Let's see. There is one other thing I did want to point out, and that's with the way that the census labels race and ethnicity. So Hispanic and Latino is an ethnicity, and so they could be any race. And that's going to be important for double counting purposes. So you'll want to make sure that you count it as a separate category so that you're not double counting across the different races. The other thing is you can choose either white alone, which means not multiple races, but it might be someone who's Hispanic could fall into that category. And then there's another category where it's white alone, not Hispanic or Latino. So just be mindful that you're selecting the data that you actually want to analyze for your question of interest. So just keep that in mind when using these tables. Okay, so that's the first thing that I wanted to show you that was related to how we collected that demographic data. So I'll pause for a quick second, and then are there any questions about that?
Allison, can you just show them that when you pull out Hispanic, Latino, then the other races should sum more or less to 100?
Yes, so if we look back at this table here, and if we were, let's see, or let's go back to this one. Yeah, so if you look at the data here and we were to do white alone, all the way down until 2 or more races, this will add up to almost around 100. It might be 99, it might be 101, but it'll be in that range of around 100. And if you were to add in the Hispanic, it would be like 115 or so. And so that's something where you just got to be mindful when you're working with this data and how it adds up or doesn't add up the way you think. Okay, so then the next question, so the first question we were looking at is how do we get demographic data for our regions? But then the second question we need to look at is what is the demographic breakdown of our employment? And so this data is going to be a different data source where we're looking specifically at occupations and employment in occupations. And so this is going to come from the American Community Survey, which is hosted by the census as well. And so these are the demographics that we pulled for the Kansas Coalition on the different demographics working with across all occupations in the state. So when we select which occupations we want to look at, we want to make sure that we're selecting occupations that relate to what our end goal is. And so as we were talking about in the South Kansas Coalition's circumstances, they're interested in things that are going to relate to manufacturing and other high-tech type jobs. And so we're going to look at occupations that fall into STEM. So we're going to look at computer and math, architecture and engineering, and then we're going to look into the middle skill occupations, which is going to be production, manufacturing type occupations. So these definitions here can be really handy to use when you're thinking about what occupations you want to look at that are going to be high paying, high wage jobs like that. And these come from the National Science Foundation. So this is a table where we've compiled data on occupations for the state of Kansas. This, like I said, comes from the American Community Survey. And what we've got here is a couple things. We have all the occupations across the state, or in other words, what is our active workforce? And then we have these occupations that we looked at in the previous slide that are related to our STEM and STEM related and middle skill occupations that are of interest for South Kansas. So we've highlighted or circled in red the ones that we're going to focus on today that are related to manufacturing. And you'll see that we've got 2 points in time. This is helpful because it allows us to see the change and the growth in employment across these occupations of interest. And so a couple of things that we can see is that within the past decade or so, computer and mathematical jobs have grown by about 3.8%. Architecture and engineering jobs have grown by about 2.1%. And production and manufacturing jobs have declined just slightly, which we suspect is probably, we can attribute to the COVID pandemic and slowdown from that. But this is helpful to see the 2 periods in time and then to look at the growth rates. I also want to mention something else about this growth rate. It's a compound annual growth rate. And what that essentially means is that we're looking at kind of like an average growth per year. So instead of looking at each individual year and the change year to year, we're looking at what on average does the growth look like. So that'll be important to keep in mind when you're looking for these changes over time. So now the question is, how did we get this data from the census or from the American Community Survey? And the census has a platform where you can get different data tables and use them to get the occupation data. So we're going to take a look at that. So let me open that up for you. So this is the platform where you can access the data, and then we'll have the slides available to you so you can use the links that are embedded in order to find this data table, as well as the quick facts and the Argonne National Lab data as well. So you'll be able to access this later as well. So let's talk about the interface really quickly. So the first thing I want to point out is that you're going to need multiple tables. And you can see in this left column over here, we have the different tables that are of interest. We have one table that's the state level table. So it's all employees across occupations within the state. And the way you can know that you're looking at the statewide table is that it does not end in a letter. It ends in the number like 10. But then if we were to look at specific tables that are broken out by race, they're going to end in a letter. So this one ends in A and it's white alone. This one ends in D and it's Asian alone. And so that's how you can differentiate the tables, is looking at this ending of the code. So that's something that's helpful to keep in mind, because we are going to need multiple tables because we're going to be looking at different demographic groups. The second thing with the interface that's important to note is where you can select your years. So like I mentioned in the previous slide, we want to compare time periods. So we want to look at changes over time. So we're going to pull multiple data tables for different years. So the first year here that's selected is 2021, which is the most available, or the most recently available. And then we might also want to select 2011 or 2016 to get either a 5 or a 10-year time period to see the changes there. So as you select your tables, you can select your time period from up here. So the second thing, or the third thing that you're going to need to pick is your geography. This particular data is consistently available at the state level. However, it's not always available for smaller aggregations. There are a few exceptions, but generally you're going to be able to get just state level. So for this case, we're going to select Kansas. So we'll select the geography icon, and then we'll go to the state and make sure that Kansas is checked blue. And once you see the check mark, it should add it to your table. So if we look down here, we'll see that the Kansas data has been added to our table. So how do we understand looking at this table? A couple things to note is that the table is broken out by gender. So we have a total number, so all people for the state. And then we have the table for male employees and female employees across the occupations. That'll be important when we start analyzing the data, because we'll need to add these sub-occupations together to get the male and female total. So let's look at the occupations. Something that's important to note about the occupations is that there's different aggregations, or in other words, there's a hierarchy of occupations. As you can see, there's these little arrows or carrots pointing downwards that tell us where in the aggregation or where in the hierarchy an occupation is located. And we're interested in finding, let's say, computer and mathematical occupations. So we're going to have to find where it shows up. So we see our highest level is management, but under management, we have several different categories. We have management, we have computer and engineering, we have education and health. And today we're interested in that computer and mathematical, which is going to be under this level here, computer and engineering. So this will be the row that we want to focus on, is going to be the computer and mathematical. So just keep in mind as you're looking through the data to focus on where is the hierarchy and which occupation title is the one that you actually want to analyze. Once you've kind of familiarized yourself with the site, with the table, you've pulled in the geography that you're interested in, the easiest way to actually use the data is to export it to Excel. There's a couple different options here. There's Excel, CSV, and zip files. I recommend the Excel because it's going to keep the same table formatting that we see on the website. And that's going to make it easier to work with and use than using the CSV or the zip files. So I've exported a couple of these different tables to show you as an example. And as you can see, when I open up Excel, it looks very much like what we were just looking at in terms of the formatting. And what you'll need to do is export the tables for all of the years you want and for all of the ethnicities and races that you want to compare. And so what you can see down here is I've got a tab for each of the tables that I was interested in exporting. When you export the data, you will need to do some minor cleaning in order to be able to analyze it. The first thing to note is that when you export the table, it's going to show you the numbers as text, and you can't really do much with text. So you'll need to convert all the numbers into text variables. So you can do that by coming up here and then making sure that everything in the table is a number. The next thing you'll need to do, like I mentioned before, is that the table is broken out into male and female, but we're interested in, for this analysis, having all people. And so you'll need to add it together. And I find the easiest way to add this data together is to create a pivot table. So I'll flip over to that tab where I've created some samples. And what you can see here is I've made a pivot table from one of those exported tables, and now I can get the sum of all male and all female employees within an occupation category. So if I scroll down to computer and math, which is the one we're focused on for this example, we can see that this number is going to be the sum of male and female. So this is just like a high-level view of how I compile this data and how you can pull it down from the ACS Census Explorer. And then what you'll need to do is then bring this into a summary table, which we're going to look at in our PowerPoint, where we can do our comparisons and our analysis. So I'm going to flip back to the PowerPoint so we can look at some of these summaries. Let's see. Okay, so we talked about this. All right, here we go. So analyzing the data. So before we get to showing the tables, there's a couple things we want to keep in mind as we analyze our data. The first thing is comparing our time periods. Are we seeing positive or are we seeing negative growth in terms of occupations? Is our growth slower than the aggregate or the total occupations, or is it faster? And then we can say, we'll need to look at how does the representation different when we look at different demographic groups versus the state total. So are we looking at, is it below, above or below, etc. So let's look at some tables and do a quick analysis. So when we pull the demographic data for Hispanic Kansans, this is a summary table of the data that we would pull from the ACS. And some things to note, we have our two time periods, so 2011 and 2021. We have our growth rates, and then we have the things that we want to compare. So the first thing is the current percent of jobs in the occupation. So this is looking at, out of all computer and mathematical jobs, how many of those positions are filled by Hispanic Kansans? And what this is saying is that 6.5% of computer and mathematical occupations are Hispanic Kansans. Then the question is, how much does Hispanic Kansans make of the whole workforce? And that's about 11.7%. And so now our question that we need to ask ourselves is this representational? Are Hispanic Kansans in computer and math reaching how many or what percentage of the total workforce there is? And the answer is no. We see that there's a gap here where there's an underrepresentation of Hispanic Kansans in computer and math, as well as architecture and engineering. And then on the flip side, we see that in production and manufacturing occupations, there's an overrepresentation of Hispanic Kansans. So the goal is to have it kind of balanced so that it would be near the representation of how many people work in the workforce. So that's kind of an interpretation of this and how to use this data to have set goals and to see what our baseline is. So we'll look at one more example. So if we look at Black Kansans, we're going to see a similar trend. And the trends that we see is that for computer and math and for architecture and engineering, there's an underrepresentation of Black Kansans, and in production and manufacturing, there's an overrepresentation. So this is kind of a setup of the table and how to interpret some of the results that you might find when looking at the ACS data. Okay, I'm going to pause for a second and pass it back over to my coworker, Jennifer.
Anybody have any questions about the information that Alison presented before we wrap up the key takeaways?
Hello, this is
Hi.
Nigel with the South Kansas Coalition. I was curious with the last table, especially looking at the gaps, if you checked, are those gaps significant, or did you do any sort of hypothesis testing to see if those gaps were significant? I know for the Hispanic table, they were a little bit larger, but at least for Black Kansans, the computer math and architecture, those gaps are a little smaller. Didn't know if those were still significant, or if those were maybe maybe not. So I'm just curious if you did any additional analysis around those numbers.
That's a good question. And that would be a next step that you could do, is you could look at the percentage point gap relative to, I mean, because one reason that the gap is bigger for Hispanic Kansans is that there are increasingly more Hispanic Kansans, right? So yeah, so that's a good point. We could do that analysis. I think the other thing that's important to note about this data is that, you know, in general, we know that people employed in STEM occupations, the jobs are more resilient to economic fluctuations. The jobs tend to pay more, but even within computer and math occupations, there's a big range of types of jobs and average wage, and same thing for architecture and engineering. So that would be another thing that you could try to hypothesize and test for is, you know, within the range of computer and math jobs, where are different demographic groups clustered.
And then another thing I was curious about, I haven't looked into this, but a few tables ago, you had the percentage change in jobs, and so there was an increase in computer math and architecture and engineering, but a decrease in production and manufacturing, and part of that might be COVID, like you mentioned. But if there's an increase in computer mathematical jobs and engineering jobs, I mean, is some of that coding and robotics related? Some of the manufacturing is shifting more toward capital intensive processes and away from labor.
Yeah, that's also an excellent point, is that this tells you people identify by occupation, but it doesn't tell you what industry the occupation is in. So exactly to your point, when we go and talk to manufacturers, increasingly they are hiring for data science people, and you know, because there's all kinds of data analytics applied to manufacturing production processes. And Dina, I don't know if you want to comment on that, because that's kind of that's the focus, right, for your group.
Yeah, I would say Nigel's pretty spot on with that. I think that's kind of what would be expected, is as manufacturing moves into more of that digital age, you will see a decrease in the number of production and manufacturing types of jobs. But I think that would be offset by in another area, or even in your installation, maintenance, and repair. I think it would probably be split across that. I think another path you could possibly look at, I don't know if this is the data set, but you know, what is that career ladder? Are people moving from production and increasing their skills and going into architecture and engineering, or are they doing something similar to that?
Yeah, that's an excellent point. Thank you, Nigel. Any other questions? Okay, well, we hope that we empowered you as researchers to use some of the metrics and data to help inform both how you approach or analyze problems, and also how you track progress against the goals that you set for yourselves. So, you know, when we were kind of reflecting on key takeaways, you know, what is useful from the data at the state level, we can definitely estimate the size of employment gaps for different demographic groups in different occupations, and you can monitor change in employment outcomes by occupation over time, which is a positive to be able to see that. What needs work, definitely regional indicators, because most of the ACS data is not available at the regional level or at the county level. I think NERD is a good first step at this, but there are still some issues to resolve with the platform. A second area that probably needs work is the fact that many of these EDA funded programs might be 5-year programs, and you can kind of see on the lead indicator side enrollment of people in different certificate programs and training programs, but employment is definitely a lagging indicator. And a third area is just that, because of the nature of economic development, you're usually targeting adults. And a question is, are some of the challenges so systematic that it's not sufficient to do an intervention at the adult level? Do you need to start earlier for a better return on investment? So those were some of the key takeaways that we discussed. I was wondering if anybody else has any other key takeaways as they work with the data and think about these issues. All right. Well, then, oh, yeah, please.
Yeah, just Sarah from North Carolina. Couldn't agree more, straddling the fact that we're kind of forced to focus primarily on adults, but trying to figure out how to lengthen that runway with engaging high school students or anticipating beyond the 2 to 3 or 4 year window. So absolutely struggling with that and hoping to find ways to do it. Thanks.
Thank you, Sarah. All right. Well, before everybody leaves today, can we just do one more quick poll? So this is our feedback poll. It's helpful for us as we try to calibrate the topics that we cover and how we present the information, just to get feedback on what changes we could make to improve them in the future. So there's 4 questions.